Hello and welcome to another episode in the EnterVol training series. This video will cover the modeling of lithology. We'll begin by importing some data. So start off in the ARC catalog. I've added a folder which has an Excel file with two spreadsheets. One defines the boreholes and the other defines the lithology down those paths. Our first step, as always, is to go to the EnterVol modeling window and create a new project. So we'll give it a name, and this particular name is a volcanic site, so I'll just call it that. Now this particular site is in Hawaii, and I know the coordinate system is UTM WGS 84 zone 5N. So we select that and we're ready to create our project. At this point we can begin importing data. We'll import the boreholes first. These are simple vertical borings. They're defined by X, Y, and ground coordinates, the depth of the boring, and the boring name. All this data is in this sheet of that Excel file. Also, since the ground surface is there, we're going to include the ground surface as a horizon. And if we know any of the materials that are on the ground surface, we can enter their names now. And I happen to know that the predominant material at the ground surface is lava, which is spelled like that. And at this point, finished adding our borings. Now I'm going to go ahead and import the lithology data also from the lithology sheet. And this is lithology depth intervals. So these are the materials along each boring with a from and to depth. So we identify our boring names, the start depth, the end depth, and the material designated to be along that path. Notice that was not created as a new material because it was detected as already existing. All the rest of the names are what we want. And we can finish. Now I can add that data to the map right now, but before I do, I want to go and select the colors that I want to use for these materials. Now the default coloring may not take into account the actual materials you're using, what they should be colored as. So we're going to go ahead and do that. At this point we can select these materials. I'm going to make sulfur a bright yellow. I'm going to use the alluvium, the pahoehoe, I'm going to make a darker gray. The colluvium, I'm going to make it a dark brown. And then finally the basalt is going to be a blue color, dark blue. So we're done with that. We can go back to our lithology and add that to the map. Color by material names, that's what I want. All right, let's see what we have. Now I'm going to add some vertical exaggeration so we can see this data better. And the first thing I notice is, because I have so much data, the borings look a bit large. So let's go ahead and change that. Go into the symbology for all symbols, and I'm going to set the width to be 2. Now those are a bit thin, but I want to be able to see through them when I do slices and cuts, so I like what I have here. Right, at this point our next step is to build models. Go back to the modeling window, go to models, and the first thing we need is our 2D grid. Now I know a little bit about this site. I've been here before, and I want to make the X resolution a little larger than the Y. But before I actually add this, I'm going to show you why I'm going to do that. If I go to a top view, notice that the X extent is larger than the Y extent. So when I show that preview, it gives me pretty good cells. In fact, they're a little larger in the X direction than they are in the Y direction. So I could have made the X resolution a little larger, but this is good enough. Our next step is to create our 3D grid. Now remember, we've added one horizon, the ground surface. So it's going to detect that ground surface existing, and the default model it'll build will be based on that ground surface and a flat bottom. It will find the elevation for the bottom for me. Because of the density of my lithology data, I'm going to increase the Z resolution also, bump that up, and we can show this model. So when the creation of the 3D grid is complete, we choose what to color it by, and the most logical default is elevation. Let's take a look at that. So you can see our ground surface conformal to the tops of our borings and a flat bottom. All right, since I'm not going to want to see that on top of my 3D model, I'm going to turn that off and go back for our last step. And our last step is to build the lithology. So we give it a name, and at this point we can accept all the defaults. We can always adjust those later if we'd like to experiment with different values. And we build the model. And once this starts, it will go through the process of reading the data, and for each material it will compute the probability for that material to exist at every node in the grid. It then goes and smooths the boundaries to determine the ideal interfaces between each material, and then constructs those structures corresponding to each of the 6 materials in our model. We're going to jump ahead to the completion, which is a total of about 6 minutes to lapse time. Once the kriging is done and the material assignments have been completed, it offers us the choices of how to color our data. We'll choose again the lithology names, and our model is created. Okay, close the modeling window, and now we're ready to do some operations on our model. Let's just be able to see into it better. First, let's just take a look. Looks pretty amazing. So let's do a couple cuts and some other subsetting operations. So we choose smooth lithology, and let's start off with a cut. We'll do the arbitrary orientation, and I'm going to cut so that I leave just kind of the back edge of the model on there. So I like that about right there. We'll say OK. Again, we're going to hide the input layer, and we're going to copy the symbology from it, the input layer being the model we just created. Okay. And we have just the back portion of the lithology. It's sort of a thick slice, if you will, where we cut away, leaving only that portion. And I'm going to do another cut. And this time let's do a cut that's at an elevation. Choose this elevation that shows me just a little bit of my bottom couple materials. Go right there. Now when we have the same symbology, we can have the two models, the back face cut and the bottom cut, intersect each other, and we'll never see those overlap areas. They'll look perfect, as you'll see in a moment. There we go. Looks fantastic. And now we're going to create a plume. And with lithology data, a plume is a subset of the materials. So the material that I'm going to turn off is the dark brown, the colluvium, and also the upper layer of So I leave checked those materials that I want to see, and it's still building this based on the smooth lithology model. It's already hidden, so we could have that turned on or off. It wouldn't matter. Okay, that's the look I'm going for. Almost done. All right. Doesn't that look interesting? How else are you going to understand those complex geologic structures? And the last thing I want to show you is that every time we build an object, let's go down and look at one of them. Let's take this cut that we did, the first cut. If you look at the properties of this object, one of the things we do for you is we add a description under Layer Properties General that tells you precisely what this object, this layer, is built on. We tell you the source file and the source target objects, that it was a cut with reversed turned on at a particular dip direction and with an origin, XYZ coordinates, and the exact time and date that it was produced. So that exists now for all objects created in EnterVol, whether they're models or layers created as a subsetting operation. And with that, I want to thank you for taking the time to watch another episode of the EnterVol training series. Thank you.